Okay, what's going on, guys? Welcome to lesson three here. Surface area and prisms and cylinders, day two. This is exactly pretty much what we've learned yesterday, but now we got composite figures. Today's notes are going to be a little weird where I'm quite literally only going to go through A and B. Then you've got group work to do. You guys are going to go ahead and try to do all of these in your groups, whatever groups you would like. It's up to you guys, right? Not the sub. And so, but the sub will have the answer keys. And so just once you finish these, go ahead and check your answers with the sub. And if you have all the right answers, you did a great job. Um, then I don't know, see if I can find something, some sort of prize on Thursday. But just again, please check in with the sub and make sure that you guys are practicing because I will be asking them to leave feedback. So on how you guys worked. So again, really weird day for notes, right? This is supposed to be an activity, but because I'm not there, it's going to have to be without me. So still the same thing, but just go ahead and try your best for today. Okay, warm up. How would you find the surface area of these composite figures? Think of painting an object and where overlap occurs. For the figures below, write out your plan of attack and how you would find the surface area in words. So how would I do this, right? I have a cylinder, and this cylinder has a diameter of 8. Remember that the diameter is double of the radius. So although we have a diameter of 8, and I'd like to place that, diameter doesn't really help me much often, but the radius usually does, right? So let's go ahead and draw the radius. Doesn't have to be perfect. Radius is going to be 4, right? If the diameter is 8, the radius has to be 4. The height of that cylinder is going to be 6. So let's go. I'm just going to make a little line here. I'm going to say this is 6 centimeters, centimeters, and has been stacked on top of the prism with dimensions 12 times 4 times 10. 12 times 4 times 10. Okay, perfect. So how would I find the surface area of this composite figure? Well, obviously we have two shapes, but notice there is an overlap. The overlap is here. Again, think about this as if you were painting something. If I was painting this composite figure, I would really only be painting around here and here and here. We are going to try to paint the base here, right? Because we are looking for that surface area. But you know where we can't paint no matter how much we try, right? Whether I move this way or that way or anywhere to try to get bases is right here where these are joined at the base of that cylinder. So when we are trying to find the surface area, we actually have to omit this base of the cylinder. So my plan of attack, you know what I'm going to do? I'm going to find the surface area of the prism. I'm going to go ahead and then add the way that I'm going to do this is I'm going to add the uh, lateral area. Let's do that. I think that's going to be the easiest way. Lateral area of the cylinder. Then I'm going to go ahead and add, remember, lateral area is just this. It is just these sides. And then I'm going to add to that the top area, surface area of the cylinder. So plus one area of a circle. And uh, and actually, before we can even do anything else, oh, and now, and again, it doesn't matter what order. And at the end, remember, so we've got the total surface area, then we have this, and we have this, but there's something we have to take away where they're joining, and we have to take away the surface area of the lower base. So minus one area of a circle. Cool. So again, this is the top of the cylinder, and this is the um, how do I call it? It's where prism and cylinder overlap. All right, let's do it. Let's get to it. Um, so wouldn't that mean that therefore area of the circle and the area, and I don't know why I divided it, but wouldn't that mean that the area of the circle and the area of the circle uh cancel out? Essentially, yes. Essentially, that is exactly what ends up happening, right? We would have to find the surface area of the circle or the prism, then the lateral area of the circle. But because we only have this, but this bottom surface area was cut out, right? It's almost as if this came down and just plugged that hole, right? So essentially, what this means is the only thing we would need to do here is just this, and we would be done. Because you could do this, but this just ends up being a zero, right? Now, um, we don't necessarily have to find any of this. Again, all it told us is plan how you would attack this. And so this is how I would attack it. And I would just let you guys work on it if you would like. But no, we are not going to solve for this. Now, how would we do this? Well, the triangle prism here has equilateral base with side lengths of 12. So boom, boom, boom. These are all 12. Equilateral base means that they're all congruent. And the prism height equals 20. A cylinder with radius 4 in the in has been removed from the inside of the prism. So now we've got surface area on the outside and we've got surface area on the inside. I know that's super weird, right? But we have the surface area on the inside that we would have to paint if we needed to. So how can we do this? Well, let's see. The way that we would do this is once again, we have to find the entire thing. So let's go ahead and find the entire thing. So the surface area first would be surface area of the prism minus, we've got two circles, one here and one here, that we have to completely remove. So minus 2 area of circles. But we have the surface area of the cylinder here. So, or not the surface area, the lateral area of the um, cylinders. So lateral area of the cylinders. And that should give me my plan of attack. Remember, these are the cutouts from the triangle. Yeah, from the triangle basis. And then this is the inside. Right? If I got like a Lego piece that was supposed to be painted and they cut a piece of it off and left the inside looking all gross and didn't paint the inside, I'd be mad, right? This is the inside of the present of the prism that needs to be covered. Sorry, I lost my train of thought. Mm, Okay. So again, we have to find all of this, all of this, all of the other side. I know. What was that, Mr. Martinez? This and this base, but we have to take away the cutouts, two circles. But now we have a surface area on the inside that we have to paint. And that's not surface area, it's lateral area. And that's how we would do it. Great. Okay. So again, you guys should know how to do this. We learned it yesterday, right? How to do all of this. Now it's up to you guys. In your groups, please go ahead and work together to try to find your whatever it's asking. So in this case, just to answer what type of three-dimensional figure this would be. I'll give you guys a hint since this one can be really hard. This would be a rectangular I could give you a hint and I just give you the answer. Prism. Why? Because it's just an unfolded box, right? This moves up, and this is my top that covers it up, and then you get a box. So if I gave you this and you started folding it, you at the end of the day would make a box. So now go ahead and start folding this, and this, and you'll notice that this we would make a uh, rectangular pyramid. A pyramid. But yes, okay. Go ahead and answer the rest of these. And again, guys, thank you for being such great sports. If you guys have any questions on any of this, I will be at school tomorrow, Thursday, and I can answer any questions. Until then, please don't hesitate to ask. I am not going to be. I am going to be busy because I'm going to be at a training for 2 days, but I will always have after school to be able to answer any questions and send any videos that you guys might need. So I see you tomorrow. Have a great rest of your day.